Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson. It is our first on electronics. Today, we will learn a great deal about the importance of electronics in our daily lives. We will also spend a bit of time discussing vacuum tube devices and their properties. We have a lot of material to discuss today, so we should get started. When we speak of electronics, we talk about a branch of science that deals with the study and design of systems that use the flow of electrons through components such as transistors, diodes, and integrated circuits. As we work through this unit, you will observe that we will build on many of the concepts that we learned in Unit 3 on current electricity. Keep these ideas in mind as we discuss new ones. Almost every device in our homes and classroom uses electronics. Electric kettles, stoves, and microwave ovens are all excellent examples of electronic devices. So are computers. A plasma television also uses electronics. Without electronics, I would not be talking to you right now. Teacher, please help the students complete a simple exercise about electronics. Students, I will give you a list of 10 items. I would like you to copy those items down in your workbook and circle the ones that use electronics. If you are ready, let us begin.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, everyone. I believe that task was not too difficult. From that list of items, which did you think used electronics? If you said mobile phones, televisions, cars, electric keyboards, electric clothes irons, and oscillating fans, you were right. Congratulations. To generate a current, many electronic devices that were created years ago relied on vacuum tubes. Vacuum tubes are the devices that are used in machines to do a variety of tasks, such as to amplify current or voltage, for switching purpose, to modify or generate electrical signals in low pressure spaces. Inside a vacuum tube, there are electrical conductors called electrodes. Vacuum tubes normally have two electrodes. Hot electrodes are called cathodes. Cool ones are anodes. As electrons are heated inside the cathode, they get faster. Some even move so fast that they escape from the surface of the cathode and travel along wires in the direction of the cooler anode. This effect, caused by the escape of electrons from a heated metal surface, is known as thermionic emission. It is important to physicists like us because, in a vacuum, thermionic emission provides us with a controllable supply of electrons. Notice that many of the devices we talked about earlier have screens that display information. Some televisions, for example, use technology called cathode ray tubes to display images. A cathode ray tube is a vacuum tube that contains a source of electrons, a series of focusing and deflecting devices, and a fluorescent screen. Electrons are fired into the tube called an electron gun. The electrons are heated by the cathode and modified by the anodes and deflection coils to create images on the tube's screen. The result is that we can use cathode ray tubes to display images on screens, such as this one. We can do more with cathode ray technology than display television images. We can use the technology to draw maps of electronic signals. And we do this using a cathode ray oscilloscope. A cathode ray oscilloscope shoots a beam of electrons through a series of deflecting plates. They are used to measure voltage and time. On the y-axis, the oscilloscope displays a current's voltage. The x-axis displays the time between voltage pulses. This is normally stated in milliseconds. Students, doctors use oscilloscopes in their work every day. In the next activity, please think of why an oscilloscope might be important in a hospital. Take a few minutes to do this now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back. An oscilloscope would be useful in a hospital for a number of reasons. But the best I can think of is to be used as a heart monitor. By connecting a patient to a special kind of oscilloscope, doctors can measure patients' heart rate, blood pressure, and other vital signs. You might even say that oscilloscopes help doctors save lives. An oscilloscope has two major functions: measuring time and voltage. In an oscilloscope, an alternating current is displayed as a wave, like this. The wave occurs because the voltage of an alternating current varies between a maximum and a minimum. If the oscilloscope's time base is switched off, an alternating current is displayed as a vertical line. With the time base on, we see the usual wave shape. In contrast to alternating current, direct currents flow in constant directions. The oscilloscope displays a direct current as a straight horizontal line. Oscilloscopes are quite useful for helping us determine the exact voltages of unknown direct currents. I think that is enough for today's lesson. I hope you learned a good deal about vacuum tube devices and their uses in everyday life. Until next time, thank you, teacher. Thank you, students.